Today we are functions, which is your first new material for Algebra 2. First learning goal, we need to be able to evaluate piecewise functions for given values, which we'll do in example 1. We need to be able to graph piecewise functions in example 2, and then we also need to be able to write equations of piecewise functions based upon their graphs. So just a little bit of background information that you're going to need in order to be able to meet these learning goals. First, we should probably talk about what a piecewise function is. And piecewise functions are functions that are represented by a combination of equations. So y equals, and then it's got these brackets because y equals two different things depending on what the value of x is. So you can see here that if x happens to be less than 1, then we define the function by the y equals x plus 3. If x has to be greater than or equal to 1, then we define the function by y equals negative 3x. So basically you've got little restrictions on there, and you have to look at the restriction values here to determine which equation you're going to use. It's not always going to be just 2 equations. There could be 100 different equations for a piecewise function. Of course, we're not going to do that in this class, but you could set up piecewise functions to have all kinds of different values. So within piecewise functions, we have step functions, which are a specific type of piecewise function whose graph resembles a set of stair steps. So it's just evenly spaced, they go up or they go down, and that is what your step function is going to look like. So a little bit like this, or obviously going the other direction like this. And they might be short, they might be long stair steps, but they're going to look like those different stairs. Okay, so let's talk about the last definition, greatest integer function. It's a specific type of step function where for each value of x that you're looking at, you assign f of x, instead of assigning it to just a random x plus 3 or negative 3x, you assign it to whatever the greatest integer is that is less than or equal to x. Now, integer, if you remember way back, I don't even know when you first defined the different types of numbers, integers are your counting numbers and their opposites. So 0, 1, 2, 3, 4, and the negatives, but it does not include your fractions, decimals, so on and so forth. A greatest integer function for notation is going to look like this. F of x equals, and then it's got like almost 2 little bracket looking things around it. So that's greatest integer x. What I would like to challenge you guys to do, and you do need to do it, at least attempt it on the back of these notes, is I would like for you to attempt to do a graph of a greatest integer function for f of x equals the greatest integer of x plus 2. And I want you to do that just using this definition. So whatever value of x you pick, you're assigning this part to the greatest integer that is less than or equal to that. And don't forget the plus 2. So on the back, when we're done with the video, I would like for you to turn it over and attempt to graph this greatest integer function. Okay, so let's look at example 1, our first learning goal, evaluating piecewise function for given values. Here, all you need to do is just be careful as to which value you're plugging in and making sure you're using the right equation. So here, I've got f of 0. So I look over at my restrictions and I say, which one of those does 0 fit into? So since 0 is less than 3, that means we're going to be using the top equation. So we're plugging 0 into this part. So 3 times 0 plus 2 is going to be my value. So 0 plus 2 obviously equals 2. So I want you to go ahead and do part B and C, and then check to see if you've gotten it correct after you pause. So when you do f of 3, you look at your restrictions. 3 is equal to 3. So that means this is also the top. So 3 times 3 plus 2. So 9 plus 2 is 11. C, when you plug in 6, 6 is greater than 3. So that's fitting into this part. So that means I plug it into x minus 1. So 6 minus 1 gives me 5. So hopefully that seems pretty simple, and hopefully you feel comfortable meeting that first learning goal. Second learning goal, being able to graph piecewise functions. This will probably be just a little bit more challenging. It'll be a lot more challenging if you don't remember how to graph a line, but hopefully we all remember how to do that. So it wants us to graph in example 2, this first function, y equals 2/3 x plus 2/3 if x is greater than 2, and y equals negative x plus 1 if x is less than or equal to 2. So what I need to do here, and there are multiple methods for doing this. I look at my first top part and I say I need to graph that line. So if I had the line y equals 2/3 x plus 2/3, how would I graph that? Now I'm going to use different colors here. I'm going to see if this has an eraser tool, but it may not. So that's where I'm going to employ different colors here. If you are using a pen, go get a pencil because you're going to need to erase some things here. That line, 2/3 x plus 2/3, remember that y equals mx plus b is how we graph a line. We start with the b. So 2/3 means that the y-intercept here is 2/3. So I need to go up 2/3, which is not quite to 1, so right about here, for my y-intercept. A slope of 2/3 means I'm going to rise 2 and run 3. So there would be a next dot. Also, I could go the other direction and fall 2 and go left 3. Would give me the same thing here. Now, normally, I would just connect that entire line, because that's the graph of the line. However, my restriction here, my constraints, tell me that I only want, so I don't want the whole line. I only want the part of the line where x is bigger than 2. Now, here's the trick. It's when x is bigger than 2, not when y is bigger than 2. So the part here where x is bigger than 2 is, here's my x-axis, just the part of the line where x is bigger than 2. Just like we did in yesterday's review where we did open circles, closed circles, this is a greater than. So I'm going to put an open circle where x is 2, and then I only want the part of that line that's bigger. Now, you should use a straight edge. I obviously cannot use a straight edge in this program, so hopefully you get the gist of how that line should look. But it's got an open circle, and the purple is the only part that I want. So you, because you are hopefully now using pencil, can erase my red dots here, because we don't need that part of the line at all. Now, I'm halfway done, because I've got another half down here. So if I go back, I'm going to choose a different color here. Let's use green maybe. And I'm going to graph this line. Should be pretty easy to graph in general. It's got a y-intercept of 1. So that means I start up 1 on my y-axis. It's got a slope of negative 1. So that means down 1, right 1. Down 1, right 1. Or up 1, left 1. Up 1, left 1. Remember that negative slopes should fall to the right. So if I connected those green dots, that's where my line would be. However, again, my constraint, my restriction, says I only want the part that's less than or equal to 2 for my x values. So, conveniently, that's kind of where I stopped. Right here is where x is 2. Now that one has an equals, so that means it's a closed circle. So closed circle there, and I want everything where x is less than that, which is going to be all of this. Don't forget the arrows, because remember it goes on forever in that direction. So the green and the purple together are what your final answer should look like. So if you're out of practice graphing lines, you may want to look for an online game where you can practice that, because you really need to be strong with that. Let's look at B. B says y equals 1 if x is between -4 and -3. Look at that pretty conjunction. See how what we reviewed comes into play here. Y equals 1. That, hopefully you remember, is a horizontal line. So that means here this should be pretty easy to graph, except that I only want the piece where x is between -4 and -3. So this is a step function, and I don't usually erase on step functions because I think they're pretty easy to graph. If you need to erase and draw the entire horizontal line, you can. I just go ahead and draw the pieces. So my equal sign is here. So that means on -4, I'm going to have a closed circle. So I go to where my horizontal line would be, where y is 1, and I'm going to make a closed circle on -4 and an open circle on -3. I only want the part of the line that's between, so just this tiny little step. And then I move on to the next one. Y equals 2, but only when x is between -3 and -2. So I go to where y is 2, close circle on the -3, open circle on the -2, and color it in between. Finally, y equals 3, so I go up to where y is 3, between -2, that's a closed circle, and -1 is my open circle. So pay attention to which kind of circles you have. That's really important. It makes a difference. Notice that is a step function. It's like little stair steps going up. All right, moving on to our third and final learning goal. I can write equations of piecewise functions based on their graphs. Now, on your actual paper, you have the circles filled in. I couldn't get them small enough using Word here. So when let me switch to black so it'll blend in, but I've got an open circle that was here on your paper, and then I've got a closed circle that was here. There is so much value in being able to work backward. And that's what this is asking us to do. Instead of looking at the function and graphing it, it's saying, look at the graph and tell me what the function was. So we need to write equations. So we can do that in pieces. It does not matter which piece you look at first. I tend to move from left to right since that's the way that we read, but it really does not matter. So I'm going to look over here first, and I'm going to draw all over this sucker. When I am graphing a line, I need to know its slope and I need to know its y-intercept. So when I'm looking at my left side here, my slope is my rise over run. So if I count from one point, which I did mark some of the points on yours, to another on this, I have rows 1 and run 1. So that means the slope of my line, I don't know why I didn't write out the word slope. I could have just used m, I guess. The slope is 1. It's a positive slope. It's going up 1, right 1, up 1, right 1, up 1, right 1. The other thing that I need is my y-intercept. Y-intercept is where that line crosses the y-axis. On this picture, it doesn't cross the y-axis. But if it did continue, we can continue the pattern, up 1, right 1, it would cross right here. So that's still the y-intercept. It's still part of the equation. So that is where y is 3. So that means my y-intercept is 3. So when I go to write my final answer, I have y equals, or f of x equals, my slope, mx, so 1x, which is just x, plus 3. Now, sometimes the tricky part for some people is writing that constraint. You have to tell me if x what? What part of it do you have? And if we're looking at just this, I call this the breaking point. Let me grab a different color again here. I call this your breaking point because right there is where it switches from one function to another. And the value of x there is x equals -1. So the values that are to the left of that breaking point line, left of x equals -1, are the part of the equation that I just wrote. So my restriction is going to be if x is less than. Do not put an equal there because that was an open circle. Open do not get the equals. So there's my first part. Now I need to look at my right side. My right side, from one point to another, I have gone down 1 and right 2. So that means my slope, down 1, right 2, is -1/2. So that means if I were just going 1 point, I'd be going down 1/2, right 1, down 1/2, right 1. So right here, that's going to tell you what the y-intercept is. That has to be exactly at -1/2. And that's not a guess. That's you using the slope and knowing that that's the point where it comes out. If you can't figure out what that point is exactly, like we can in this case, then you would have to use your point slope formula. So if you don't remember point slope, learn it because we will need it this year. Y minus y1 equals m times x minus x1. And you would plug in one of these points. Say, plug in this point, 3, -2 for x1, y1. Plug in your slope and figure out what it could be in there. Well, actually, we wouldn't do that. We would plug in this actual point. We would plug in when x1 is 0. But regardless, we don't need to do that in this case because we know using our slope that I would go down 1/2 and right 1. So I'd end up right here at -1/2. So that means my m is -1/2, my b is also -1/2. So that means that my equation would be y equals -1/2 x minus 1/2. My restriction, hopefully easier the second time around, is when x is greater than or equal to -1 because it's from this point, which is where x is -1, and bigger. And it has the equals because it was a closed circle. So do not forget, I know we get to the end and you forget about the challenge that I already told you to do. So if you had forgotten, don't forget, on the back, I want your best attempt at graphing that greatest integer function based on its definition. And that is it for today.